Hey everybody, Mr. Buggo here with some information on 5.7 from geometry, which is on the sums of the measures of polygons. So we're going to kind of look at those things here, kind of break this down one step at a time, one video at a time. So we're not watching a video that's about 20 minutes long here. So I'll kind of break this down. On this one, what I'm going to talk about here is the triangle sum theorem that we have on the screen, which we are familiar with, we've seen before. And then we're going to use that to show that the quadrilateral sum theorem is true. That says that the sum of the measures of the angles of a convex quadrilateral is 360 degrees. I'm going to use this idea that the sum of the measures of the angles of a triangle is 180. So I have a quadrilateral here on the screen, and I've already measured all the angles. So this angle right here is 88.48. This one here is 106.24. This one here is 89.04 and then 76.25. I apologize that they're decimals. I'm going to kind of manipulate these here in just a minute. So that hopefully won't matter and we'll get the idea. What I want everybody to kind of focus on here is that I've taken all of these values. I've taken, and I apologize for the Greek letters here of alpha, beta, and delta, and gamma. So I apologize for those, but notice that the variables here are all being added together right down here. So when I take those three values and I add them together, I get 360 degrees. Not a coincidence. That's a quadrilateral sum theorem. And even if I manipulate these things and move them around, if I take this point A and just kind of move it, you'll notice that as I move that, the angle is changing because the sides in relation to each other are changing as well. This down here, I still have a convex quadrilateral. Now this angle here is 72.7, 106, so on and so forth. And notice when I take these four and I add them together over here, it still stays 360. That's not a coincidence. That's exactly what the quadrilateral sum theorem is. That's based on the triangle sum theorem, that the fact that a triangle is 180 degrees. So I can take this and kind of illustrate kind of where that's coming from. If I want to take this point and connect it to this point, you'll notice that I've separated this quadrilateral into two triangles. And if I just look at this triangle here should have angle measures that add up to 180. Same thing with this one over here. And 180 plus 180 is 360. And what's happening there is essentially taking this 99 degree angle. I'm sorry for that stuff getting in the way there. And we're not cutting it in half, but we're dividing it into two pieces. So we get half of the, or not half of, but part of the 99 comes over here and over here. So what we have here is a quadrilateral that adds up to 360 degrees and will always be the case no matter how I move these. So notice again, if we look at this right here, as I move these sides, that 360 does not change because the sum of the measures of the angles of a convex quadrilateral is 360 degrees, and that will always be the case.